Welcome back. Let's talk about the most exciting machine in a machine shop, the bandsaw. I want to talk about the bandsaw because I'm working on a project regarding the bandsaw. I'm making a sliding infeed table, as I already have shown in the previous shop talk video. And this is going to be a general build and discussion video. Unfortunately, from the machining footage that I got, I had to do voiceover because at the time when I was machining the parts for this, I had the CNC machine scream out parts for a production job, so I wasn't able to do proper commentary, so it's voiceover. Quick history about my bandsaw in general. This started out as a 4x6 or 115mm sized bandsaw, horizontal bandsaw. I bought this saw for like $50 on eBay. It came in 2 boxes, was in horrendous condition. The electric layout consisted of some loose wires and a light switch. So I rebuilt it one time to be kind of original. That's what you see here. Then the original gearbox gave up the ghost, so I pulled off the original motor and gearbox. I purchased a used industrial right angle drive motor with a gearbox, put it on there and added a VFD. That made the saw already 1,000 times better. And I made a saw table for it because when I got the saw, it was only horizontal, and the saw table that usually comes with this type of saws was missing. So I made one out of hot rolled steel plate and some angle irons. That worked perfectly fine. And then I decided that I don't need a horizontal saw because horizontal saws take up a huge amount of floor space. Means I ditched the base plate of the thing, made a stand. That's the stand the machine is sitting on currently, and I'm using it ever since then like this. And every time I see Robin Renzetti using his roll-in bandsaw, where the table is stationary, the part is clamped, and the saw, the entire saw is moving into the work, I'm a little bit envious because this gives a lot of options for not only stock, cutting stock to size for machining, but also for material removal when you do machining. Slicing off a large chunk of material is sometimes more economical and faster than chewing away with a face mill. A good friend of mine, when we moved a Maho 400P milling machine in his shop, I saw some tiny NSK linear guides, and well, those ended up in my shop, and I built this thing. This is still unfinished, it's a prototype. This will definitely be a 2-part video because currently I do not have the time to finish it, but I want to get the video on the saw table out. So let's look at what's the current status of the saw table and look at the machining, and we'll go from there. This is the current state of the machine. I have, here's the bandsaw blade. By the way, I use usually the most coarse blade I can get for the saw, which is a 6 to 10 variable teeth. Don't even think about putting a fine blade on these saws if you want to cut thick stock. It's completely useless. I would prefer a 4 to 6 teeth if I could get one in this size, but with the 13mm or half-inch blades, you're very limited in the coarseness of the blade. The table plate itself is a 17mm thick ground steel plate. I didn't grind it myself. I purchased from a tool and die supplier a pre-ground plate, medium carbon steel, because that's the simple steel that they have. Comes pre-squared, pre-chamfered. It's very nice to work with. And the fence is 20mm by 70mm. Also medium carbon steel, pre-ground stock, pre-squared, and it's just bolted and pinned in place. I have a huge chamfer down here on the lower end of the of the fence to allow for chips if you clamp something square with a sharp corner, and this just gives room for chips, or if the stock you clamp has burr. And the saw blade comes through the fence from the back. The plate is slotted all the way through to the front and held together in the back by about this length. Drilling the plate that forms the actual sliding table, these holes in a linear array hold the linear rails to the table later. Drilling 2.5 millimeters and then tapping M3. Here I'm milling the clearance slot for the bandsaw blade to ride in. Yes, I need to change the coolant on this mill. On these tool room machines, the oil from the axis lubrication all goes down into the coolant tank, which is definitely a problem, as you can see by the color of my coolant. Especially when you don't use it very often, the coolant gets quite yucky quite fast. Using a 6mm roughing end mill at 2000 RPM, and I'm taking, I think it was like 5mm deep cuts in multiple passes to get through the plate. The reason why this entire video is voice-overed can be seen here. The CNC is running production in PVC, and I'm running an extremely long ball nose end mill which screams like crazy. Drilling the fixed jaws for the infeed table. These are 70mm tall, and the quill of the Deckel FP1 only has 60mm of travel, so I'm drilling as deep as possible with the quill. Then I raise the table a few millimeters so I can drill all the way through the part. The fixed jaws of the clamping arrangement, just 20 by 70mm pre-ground medium carbon steel. Using the power feed to get the tool back out of the bore. And I even had to pull the drill out further from the drill chuck to finish the bore. This is not a long series drill. The central hole is for the screw, and the outer two holes are for dowel pins. So we countersink them a little bit. The screw hole, of course, gets also a countersink just to deburr it and make it clean. And then we change to a 6mm 6H7 machine reamer. And we ream about 10mm deep to give, so we can put a dowel pin in there. The other side of the fixed jaw requires a very deep counterbore, because I don't want to use an awful long screw to hold the jaw in place. So Flipped the part over, went over to the drill press, aligned the screw bore with a stepped drill. This is a step drill for a M6 screw, so it creates the correct counter bore. Aligned it, clamped it in place, and then just counter bored it to depth and left about 10 millimeters of material on the bottom for a screw. And the idea behind this is you put in your stock. Let's say you have this piece of round stock. You can nicely align it. And then you have this quick action clamp, which you just push up against the stock, lock it, and then you can bandsaw through your stock. Both sides of the stock are held, kinda. It averages itself out a little bit. But this way of holding the stock against the fence gives some options. Let's say you have this piece of, well, that's the fence material. Let's say you want to slice off a corner of it to make a huge chamfer. You can just do this and bandsaw into it. And yes, currently I'm bandsawing into the fence, and it will stay that way because it doesn't matter. I will add a vertical stop that runs up against the guide block up here for the saw blade, so it doesn't cut all the way through. This clamp here, you can get these clamps as a standalone version from Heinrich in the USA. They make them. They make also a drill press vise, which is very similar. I could not source this clamp here in Europe from Heinrich for a reasonable price, so I went on eBay and I purchased a import drill press vise, which has exactly the same mechanics, and I just sliced it apart and made it work for my purpose here. Since I couldn't source the Heinrich clamp that Robin Renzetti used on his roll-and saw modification, I found this on eBay, or should I say, a friend found it on eBay and sent me a link. This is a quick action drill press vise that works 100% the same as the Heinrich clamp. You have a smooth clamping bar that gets pushed in and out. You move it up to the thing that you want to clamp. Then you have this cam lever here that locks it. The mechanism behind this is surprisingly simple. We'll flip it over in a second. But this drill press vise is about 100 euros. The Heinrich clamp alone, only the clamp with the bar, is $300 US. Yes, this is an import vise, of course. And to be honest, it's not terrible. Since I'm going to destroy this one for salvaging the clamp section out here, I consider buying a second one for the drill press because I really like it. It's a nice form factor, it's a nice size. The quick action seems to work very well. You get about, I would say, 3 millimeters of movement out of the cam action here. So let's flip it over. Let's get a rag on here so I don't mar up my table. So you have the quick action bar that with the cam lever open can move in and out freely. And you have this piece here. There is an eccentric on the cam lever here that tilts this piece a little bit, so it locks itself to the bar. I guess the hole in this piece is a little bit oversized, so it can tilt, then it locks itself. Just like on a welding table with straight holes when you put in the clamp, and with the tilting action it locks itself into a bore. And then the eccentric moves this tilted plate that's grabbing onto the round bar forward, and this creates the final clamping motion. And the spring here is to push everything back in starting position. And this seems to be some kind of a adjustment for the 0 position of this locking plate. Okay, let's get this thing apart. Let's see. I would like, okay, this is moving freely. So it would be nice to get the bars out. I suspect that they are just pressed in. So I'm just going to give it a mild tap with a hammer. Okay, let's see. I have a drift and a small hammer here. So yeah, it's sliding off the table, but also the bar is moving. So let's bolt it down. Okay, let's see. There we go. It's not really tight in there. The end of the bar is knurled and then pressed into the casting, which is a very simple way to create a press fit. Ah, yeah, there is a set screw. Okay, there is the moving jaw. It's really, for what it is, it's really nicely machined, and I'm highly considering buying one of these as a drill press wise. So next plan is to just bandsaw it in half, about here. Okay, I set it up on the bandsaw here, clamped the vice body to the fence of the infeed table, and I'm just slicing off this end. So, judging by the chip formation, this is gray cast iron. So, as you saw, this cuts really nice. Okay, there we go. One slice. I need to drill the underside of this casting, and I just took an end mill and cleaned up the bandsaw cuts on this casting. Now I need to hold it some way so I can drill 2 M6 threads to mount it and 2 dowel pin holes to align it on the infeed table. I can't just rest it on the back here because this is an unmachined cast surface. I can't hold it like this in a vise because there is draft angle to the sides of this thing. Quite the annoying piece to hold, but I figured I can use an angle plate and I can clamp it against the angle plate like this and use this surface that I machined on where I bandsawed it off as a reference surface to the bottom surface. This is square to each other, I checked that. So I have an angle plate here. I have some precision keys here. These fit into the table into the T-slots and are ground to a precise width as a pair. And these are an extreme quick way to get some semi-precision out of a setup without having to use a dial test indicator. For something like this is more than adequate. So now we get this onto here. And I'm just using an F clamp. To hold it in place until I get 2 strap clamps in place. If I had 2 large cant twist clamps or 2 large C clamps, I would use those, but the Woodworker's F clamp is not, this won't hold up to the forces of drilling into this casting. So that's the clamp arrangement I'm going with. It's not ideal, but it's what I have at hand and what will work. Would be nice to have something soft between my scraped angle plate and the support screw that I'm using here. Okay, after 5 minutes of searching, I found 2 10mm wrenches, and now I can tighten this down. Yeah, it's truly not ideal. But it only has to withstand some light drilling and tapping, and I can put 2 screw jacks under it so it doesn't get pushed down from the forces of the drill. So I'm building the same clamp on this side too. You don't need to see that, and then we're aligning the top. Okay, let's get the F clamp off. The F clamps and the Fabricator style forged clamps are always nice as a third hand. Sometimes these are a little bit better. The forged one, these have a little bit more spring and hold better up to vibrations in your setup. Sometimes these are way good enough for a machining setup, as long as you don't have to support downward force, like against sliding. I wouldn't trust it that way, but sometimes these are perfectly fine for machining setups. These ones with the cast jaws tend to loosen themselves instantly with any vibrations. If you have the option, these are nice. They are fairly expensive. We call them Spannhand. They come with a nice Acme thread here, and you can really reef down on these, but the larger ones get very expensive very fast. The 75mm is the largest one I have in my shop. Now we need to run an indicator along the top and use a soft-faced hammer to tap it level. I'm using a dial test indicator on the original machine surface of the part just to get it level. And I'm already pretty darn close. Let's start at 0. Okay, that's 0, 0 side to side, just with some mild adjustment with a hammer. I'm going to torque down these screws a little bit more. Yes. So much for that. I guess we reset up. Wow, that's annoying. So yes, nothing annoying ever happens in my shop. All of the YouTube machine shops never have issues. Everything is first go perfection. Let's try this again. Down here on the side you can see the screw jack supporting the casting, and I will do the same thing on the other side. This is a screw jack with a dowel pin on top. Looks like this. They are made out of free cutting mild steel. They have a M10 by 1mm fine thread. They have a base that makes them higher. And there is also a second, a different thickness for the base. And they are drilled and reamed on top to accept a 6mm dowel pin. If I need not a flat surface to support something on, but a point support, like you would support a casting. So, rather useful item. Here I'm using an edge finder to find the center of the casting. I could also go off the bores in the casting, putting a gauge pin in and edge finding on the pin, but I'm not entirely sure why I did it this way, but I previously confirmed that the casting is very centered to the bores, or the other way around. The bores are very well centered in the casting. So edge finding on the casting was not a big deal. What I'm doing is I'm edge finding on one side, zeroing out the DRO, edge finding on the other side, and then splitting the measured distance in half. That gives me exactly the center of my casting. Same as in the fixed jaw, 2 dowel pin holes to locate the casting on the saw table. Ream 6H7, so this is a press fit for a 6mm dowel pin. Drilling 5mm holes, which is the tap drill for a M6 thread. And as you can see, I'm drilling dry. This is gray cast iron, and with cast iron you have to go either all in with coolant, means flood coolant and you flush away all the chips and fine dust created, or you go dry. Otherwise, if you use just cutting oil or a little bit of coolant out of a squirt bottle, you create this rather abrasive slurry with the fine cast iron dust that's very hard on the cutting edges of the tools, creates an awful lot of friction in the bore, and just makes not for a very nice drilling experience. Power tapping on the decal. So you can run the tap under power into the bore, but you have to unwind it by hand because from factory the machine does not have a reverse. So you just put the drawbar wrench on the top of the spindle and unwind it counterclockwise. For a bunch of threads it's usually perfectly fine. You can also use this like a sensitive tapping attachment, and you can just tap by hand with the spindle disengaged from the gear train. That's nice when you have to tap very closely to a blind hole, very closely to the bottom of the hole, and you have a good, you feel what's going on there. and I added this this movable jaw here, this very wide and very tall. The fence and the jaw are so tall that you can clamp very large diameter round stock. Cutting this piece of steel in half, 130 millimeter diameter, 10 millimeters thick, just happened because I was bragging in the last video how this would be possible by just standing it upright and running the saw blades through it. And I wanted to stand by my word. As you can see, it's not a big deal. It just took rather long because saw blade is rather dull, and hand feeding it through there is a little bit tedious. But overall, the cut is not a problem. The parallelism is about 0.2 to 0.3 millimeters currently, but nothing on the infeed table is properly aligned to each other yet. It's just bolted together. You need to clamp above the center line of round stock to clamp it securely. So this setup gives me a clamping range of 140 millimeters and smaller diameter. And this is also kind of the size limit of this bandsaw. So my overall height capacity between the table and the lower bandsaw guide is 150 millimeters and a little bit. So a clamping capacity of 140 millimeters is perfectly fine for what I do usually. The vise opens also 150 plus a little bit. If I want to do contour sawing, like cutting out the shape of sheet metal, this comes off with 2 screws from the bottom. It's pinned in place. Just lift it off, and the 2 fences also come off with 2 screws, and you just lift them off. They are also pinned in place, so they go back very precisely. Currently it's hand feed, you just push it in, but one addition that I want to do is a pneumatic infeed. Pneumatic infeed has a little bit of problems because air is elastic, of course, it's compressible, and that doesn't give a very precise infeed, but there is a solution to that. I don't want an electronic infeed with a lead screw or something like that that just adds electric complexity that I don't want to deal with. It's the same as an electronic lead screw. I have progressed far enough in my life that I like to keep things kind of simple if possible, and put complexity where it's necessary. And the infeed of a bandsaw doesn't need a servo or stepper drive in my mind. So that's coming. Currently it's hand feed. Could also just be a gravity feed and a oil-filled cylinder for braking. But the thing with weight or gravity feed, you need quite a big weight to get some gravity in there if you don't use tungsten or uranium as a weight. Tungsten is very expensive and uranium is very spicy, so we don't use those usually, if we can, for counterweights. So that's the infeed table, and as you can see, it runs on these 2 rails. It's very free running. It's currently held together only with kind of 4 screws because it's all not aligned. And what else? Safety. Well, yes, that's an awful lot of bandsaw blade exposed, but I'm a grown-ass man and I know where to keep my fingers when I run a bandsaw. Also, the bandsaw table is really way more safe than running the bandsaw in normal table configuration. Also, I have this handle here. I might put it like in the back to push, or here on the side to move it in and out. Down here you see the original welded table construction that I built years and years ago. Huge square tube with end caps as a main chassis, 2 angle brackets, one here and one on the back side, and 8mm steel plate on top as the table. So I had to pull this off and put it on the milling machine to do some minor milling and drilling to mount the 4 trucks of the linear guides. modifying the original saw table that I made years ago. The Deckel FP1 has only 150 millimeters in the Y direction, so I could not drill all the holes in one setup using the vertical head. So took off the vertical head using the horizontal spindle, clamped the work standing upright on an angle plate. Using the angle plate here because that way I can clamp on the machined lower surface of the table, which is my reference surface here. And then it's just going by coordinates and drilling all the holes as necessary. I also use an end mill to surface the area where the linear rail trucks mount to, because this is just hot rolled plate and I never bothered to face mill or grind the top surface. And it was not flat, so that's the reason why I did the milling there. Deburring all the holes using one of those crank style hand deburrs with a countersink on the end. I kind of like these. They are single flute countersinks or deburr tools, and they work very well to leave a nice surface. Using the die grinder with a fine cut carbide burr to give all the edges a chamfer. When you do deburring with a die grinder, you preferably always want to go climb cutting and take very light cuts. Don't get greedy, don't try to take off too much material in one pass. You will end up with chatter and the cutter grabbing into the material. Test fitting the linear rail, just have it sit on there to get an idea if what I'm building here is plausible. And this is how the table mounts to the bandsaw. It's located with 2 pins and held in place with one M8 screw in the back. The 2 pins located perfectly fine and keep it from rotating, and the screw, well, holds it in place. Using my shop-built chamfer milling machine that's just clamped to the drill press table to chamfer all the machine parts, give them a nice 1mm chamfer. Later I use a hand file and some emery cloth to ball over all the corners. That's important in my mind. Chamfers make edges safe to touch, but there are still the corners where all the chamfers of a part meet, and those often are very pointy and very sharp and a good place to get catched with your hand and slice you open. So ball those over it if they are in an area that's handled a lot. With the rails in place, next part that goes on is the actual table. You have to slide it on from the back around the saw blade and then drop it onto the linear rails. Doesn't go any other way. You could remove the saw blade, of course, which would make it easier, but that would mean you have to remove the saw blade. Linear rails the trucks are bolted to the table from the underside, and the linear rails are also bolted onto the table on the upper table surface from the bottom with M3 screws. So the rear fences come into place. They're pinned in place. The holes in the table are slightly oversized. This one is a little bit wants to stick, and they just drop into place, and there is one screw in the center that holds them in place, and that has so far proven to be absolutely suitable enough. So this is end of part 1 on this bandsaw infeed table. I hope this gave you a good idea, the general design and how I set it up, and some of the machining. So part 2 will mostly be detail work, like slicing off the linear rails, putting everything together for real, figuring out some kind of chip wiper, things like that. The detail work. And I'm not promising the infeed for part 2 yet, because I don't know how much time I will get into this table. But so far it's working very nicely. Even with hand feed, the power feed is not a really pressing need. So we'll see. Thank you all for watching, and I'll be back.